Hello everyone. In this video, we are going to discuss about the limitations of single stub matching. So before entering into double stub matching, we should know what are all the limitations of single stub matching. So the first limitation is the stub has to be located at a definite point. Okay, so the location is to be definite on the line. So single stub is adequate for open wire line. So this single stub matching is adequate for open wire line alone. So the location of the stub is definite and also the single stub is adequate for the open wire line. So for the coaxial lines, placement of stub at exact point is very difficult. So it is very difficult to place the stub at the coaxial lines. Okay, so that is one of the drawback of the single stub matching. And coming to this third point, two adjustments were required in single stub. So this being the location, that is the position of the stub and also the length of the stub. So we have to make the two adjustments in the single stub matching. And coming to the fourth point, this technique is suitable for fixed frequency only. So here the frequency is fixed. If frequency changes, the location of the stub has to be changed. So for the different frequency, we have to change the position as well as the length of the stub. So to overcome this difficulty, double stub impedance matching is used. So to overcome all these limitations, we can use the double stub matching. So in the system, two different short-circuited stubs are used for impedance matching. So the location of the stub is arbitrary and the spacing between the two stubs is made by lambda by 4. In the single stub matching, the spacing is made by lambda by 2. So here the spacing D2 is frequently made lambda by 4 and the spacing of 3 lambda by 8 is also sometimes used if the first stub is to be located very near to the load. So if you want to locate the second stub which is very near to the load, we can use 3 lambda by 8 or else we can use a spacing of lambda by 4. So lambda by 2 spacing is avoided because it places the two stubs effectively in parallel at the same point. So we can avoid the lambda by 2 spacing in the double stub matching. So we can go for either lambda by 4 spacing or 3 lambda by 8 spacing in the double stub impedance matching.